Everyone, this is Dr. V.H. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic Clipper circuits using operational amplifier from the unit Applications of Operational Amplifier. In this video, we are going to see clippers, its types and working function of each types and its input-output waveforms and its application and assessment. Before going to the topic, we need to see what is clipper. A clipper is an electronic circuit that produces an output by removing a part of the AC input signal above or below a reference value. Okay, so we can modify the given input signal based on the need. So that is the main use of the clipper circuit. The main advantage of clipper is that they eliminate the unwanted noise present in the amplitude of an AC signal. Okay, coming to the classification, under the series clippers classification, we are having two different types, starting with positive clipper and another one is negative clipper. A positive clipper is a clipper that clips the positive portion of the input signal. So we can see here a diagram of positive clipper with an op amp along with the diode D1. Here the two voltages are given to the input path. So that is, for a positive terminal we are giving input AC signal and the reference voltage is given based on the R2 value. So the value of reference voltage V reference can be chosen based on the resistor R2. So this is the circuit we can use for the positive clipper. Now we can see based on the Vi and V reference value how the circuit produces the output. Okay, here we are having a condition when the value Vi is less than V reference, diode D1 will be conducting. So here in this diagram, so when we are giving a positive terminal, we are giving the Vi input to the positive terminal, where up to the value Vi less than V reference, the diode D1 will be conducting and producing the output, and it acts like a voltage follower circuit. So whenever Vi goes more than V reference value, the diode D1 will become off and no output will be provided. So this is the two condition we need to know about the positive clipper. So we can see the waveform, input and output waveform based on the two different values. So that is one is positive V reference and another one is negative V reference. If we are seeing the positive V reference, the above diagram, we are taking the positive V reference as 1 volt. So when Vi is less than positive V reference, the output was produced. But when Vi starts moving above the V reference value, that is plus 1 volt, the out D1, because the D1 is will be in off condition, there won't be any output. That we can see in the left side bottom diagram. That is nothing but the output waveform of the given Vi value. Similarly, in the right side diagram topmost, we are taking the V reference as negative, that is minus 1 volt, and we are seeing here how the Vi input is produced as the output through the positive clipper. Similarly, in the same way, we are having the next type that is called as a negative clipper. A negative clipper is a clipper that clips only the negative portion. So similar to the positive clipper, so that positive clipper clips only the positive portion of the input signal. Similar to that one, a negative clipper clips only the negative portion of the input signal. So here the position of the diode will be changed when compared to the positive clipper, and the input terminals are same. Vi is given to the positive terminal and V reference will be given to the negative terminal of the operational amplifier. Okay, similar to the positive clipper, here in the negative clipper we are having two conditions, starting with Vi less than V reference. So Vi, if Vi value is less than V reference, diode D1 will conducts, Only whenever Vi is less than V reference, diode D1 will be conducting. So when the condition Vi goes less than V reference, diode D1 will be off in condition. So that is the characteristics of the negative clipper. So based on these two characteristics, we are having the input output waveforms. Similarly, we are taking the minus 1 volt as the V reference and plus 1 volt as to V reference. The two examples are given and discussed here. So whenever minus 1 volt is taken as the V reference value, so if you are giving some sine wave as an input signal, AC input signal, the negative portion, so that is whenever Vi greater than V reference, the diode will be conducting. Whenever the Vi goes less than V reference, diode will be in off condition D1. So that is shown here in the left hand side. And similarly, another example, V reference with plus 1 volt is shown in the right hand side. So if you are taking V reference in the plus 1 volt, so as per the condition discussed in the previous topic, so that is previous slide, whenever Vi is greater than V reference, diode D1 conducts. So in the right hand side diagram, so whenever Vi is greater than V reference, diode D1 will be conducting, and whenever Vi goes less than the V reference, that is plus 1 volt, the diode will not be conducting, zero output will be obtained, which is shown in the below diagram. So this is about the negative clipper working and its input output waveforms. So finally, we are going to see the clipper applications. So where we need the clipping of the given input signal. So that is discussed here in this slide. Waveform shaping used in applications where specific waveform characteristics are required, such as in digital communication and digital computers. And voltage limiting can protect sensitive electronic components from damage caused by voltage surges or overdriving. Noise reduction used to reduce noise spikes or pulse that are above or below a certain threshold, and also used in radio receivers to remove noise pulses and radar systems to limit signal voltages. So these are the several applications of the clipper circuit. Okay, in this video we have discussed what is the clipper circuit and what are the types of clipper circuits and what is its working and what are the waveforms. Here we have discussed input output waveforms and finally the application. So here we are going to discuss the assessment questions. The clipping level in the op amp is determined by reference voltage is the right answer. In a positive clipper, the diode conducts when Vn is equal to V reference. What happens if the input voltage is higher than reference voltage in a positive clipper? Output voltage will be equal to the reference voltage. So these are some assessment questions based on the video, and here are some reference links to discuss this topic, clipper circuit. Okay. I hope everyone is clear about this topic. We can see in the next video. Thank you all.